So we started a process yesterday of separation of variables, and we are going to kind of build upon it. I'm going to go through another of kind of the more complicated type of problem, and then ask you to try a little easier one. So here we go. First thing in separation of variables is to separate the variables. So we're going to put everything with y on one side and everything with x on the other. Here's where it gets complicated. It's already gotten complicated. Because there's a y here and there's an x here, and we need to separate them. So we can do it. We need a way to separate those variables. Equals cosine of x times, and we're going to do the same trick that we did on the last example yesterday, which is to say that if I have addition up in the exponent, rule of exponents says I can separate that out with multiplication. So I can say that this is cosine of x times e to the y times e to the sine of x. So I can separate those out. So I'm going to separate those variables. I'm going to divide by e to the y. 1 over e to the y, just to make it easier to do antiderivative, 1 over e to the y is e to the negative y. Right? If the exponent's going on the bottom, that's just e to the negative y. And then so that was kind of the tricky part of this problem, is getting that. And then we have tricky part number 2, which is going to be solving for y. Because you'll notice that there's a y up in this exponent. It's still going to be up in that exponent when we do antiderivative, which let's do that next. Antiderivative of e to the negative y is e to the negative y. But since it was negative, to undo the chain rule that is going to happen, we'll put a negative out in front. Negative e to the negative y equals antiderivative of e to the sine of x times cosine of x. I will skip over the u substitution that some of you might be more comfortable with doing for this part, and tell you that the antiderivative of e to the sine of x times cosine of x is e to the sine of x. Plus c. I'm going to go ahead and get this negative out of the way. So that means we're multiplying this by negative 1. So this is negative e to the sine of x. A negative number is still a number. So it's still plus c. And now we need to separate out and make sure to get y by itself. And the way that we can bring an exponent down is by taking the natural log of both sides. because our natural log of e to the negative y means that, since I have the same base here, that means the negative y can jump out in front. So we have negative y times natural log of e, which is 1. So we have negative y times 1 equals, and then natural log of negative e to the sine of x plus c. And now we're just going to plug in our point, which is 0, 0. 0 equals negative natural log of negative e to the sine of x to the sine of 0 plus c. Plugging in 0 for x. And I could solve this equation, but I know that this means that negative e to the sine of 0 plus c. In order for this to be 0, then what should be inside the natural log is going to be 1. Because the natural log of 1 is 0. So what needs to be inside here is 1. Because if I have a natural log of 1, that's going to be 0. Negative e to the sine of 0 is 0. E to the 0 is 1. So I have negative 1 plus c is 1. So c equals 2. So my final answer here is y equals negative natural log of negative e to the sine of x plus our c is 2. So 2 tricky parts in this problem where people might get stuck. Tricky part number 1 was separating out those variables because we needed to say that adding the exponents means that I could separate it out with multiplication. And then fast forwarding, tricky part number 2 was the fact that I had some things out in the exponent here, and I needed to take the natural log of both sides to bring this out in front and bring the y out of the exponent. So it was like how to get the y separated from the x and how to get the y out of the exponent were the complicated parts of that problem. And again, this time I solved for y first and got y by itself, and then I plugged in and solved for c. But on some of the problems, we can solve for c first and then get the process of getting y by itself. Just depends on the problem, and sometimes it just depends on what you personally find is easier towards solving it. Okay. I want you to take about 5 minutes and try this next problem. It is not as hard as this one. You can play around with this a little bit. In fact, I'm going to. Let me change this. because I know the antiderivative on the left is going to get a negative, and the antiderivative on the right won't. So I'm going to move the negative over there too. So then it'll cancel out and be a positive. Antiderivative here is a positive 1 over y. Antiderivative here is x squared plus c. So let's get y out of the bottom by multiplying by y on both sides. And now we can divide. X squared plus c moves down to the bottom here. And now y is by itself, and we can plug in our point. Y is 1/4 when x is 1. 1 over 4 equals 1 over 1 squared plus c. And so this means we want the bottom here to be 4. You can do some fancy multiplying and that kind of stuff, but really, we want the denominators to match. The numerators already match. So y equals 1 over x squared plus our c is going to be 3.